My name's Adam Driscoll. You might have seen me around this week. And I'm going to be talking about building cross-platform PowerShell modules. This is going to be our agenda. Talk a little bit about PowerShell Core. Talk about some of the differences between Windows PowerShell, PowerShell Core. Talk about some tools and methods I've been using to work on different platforms and kind of identify when I'm running on different platforms. Testing modules using Docker instances, probably the easiest way to test your cross-platform modules. Then we're going to talk about some basic binary modules and kind of how you set up a binary module to run anywhere. And then I'm going to tell you a story of a complex binary module and some of the things I've run into trying to build a cross-platform module. So a little history of PowerShell Core here, I guess. I think the first official version was released on January 19th of this year. And now we have two flavors of our favorite little scripting language. Windows PowerShell, PowerShell Core. So there's dozens of new platforms to support: Windows, Windows IoT, OS X, all those different flavors of Linux. And then it also runs on ARM. So I've actually had it running on my Raspberry Pi. So that brings a golden age of incompatibility. So there is differences in the language, differences in some of the core commandlets. You're seeing some of the new core commandlets have additional parameters that Windows PowerShell doesn't have, that kind of thing. Differences in aliases. Curl is a widely used Linux tool, and that used to be an alias on Windows with Windows PowerShell. Many missing modules. Jeffrey kind of went through some of the things that Microsoft is doing to alleviate some of that pain. And I'll show you some of the tools that we can use to do that too. Different .NET runtimes. I'll talk a little bit about what .NET Core is versus .NET Framework. Different installation directories. PowerShell Core was the program files, while Windows PowerShell has been historically in the Windows system directory. And then they both have different PS module paths. So although they're the same scripting language, there's a couple things that are different between the two. So some really simple things you can do to kind of identify where you are and what you're running on are use some of the new built-in variables and additions to PS version table. So if you're running PowerShell Core, you're going to have access to those top 4 variables there: is Core CLR, is Linux, is Mac OS X, and is Windows. And depending on which operating system you're running or which particular framework you're running on, you'll have that either true or false. And you can see that PS version table is actually different between Windows PowerShell and PowerShell Core. In version 5.1, I think they added PS Edition, so that's desktop. And then when you're running Core, it's actually Core. And then you'll have access to things like the OS and platform on Core, as well as the Git commit ID, which is kind of cool. All right, a couple tools to help you alleviate some of the issues between going just Windows PowerShell to PowerShell Core. So this isn't necessarily making you more cross-platform, but this is making sure that your modules work in both Windows PowerShell and PowerShell Core. So there's a repository up there called the Windows PowerShell Compatibility Pack. It's nothing but a README right now, but it has some of the things that Microsoft is looking at doing in terms of alleviating some of the problems with like missing modules, WMI compatibility. I think maybe that's where the install R module will end up, that kind of thing. Then there's the PS Core Windows Compat module. That's a community contribution that's up in the PowerShell gallery. And what that does is it brings in some .NET types that you would expect to be in PowerShell that aren't there by default in PowerShell Core. So when you import it, all it really does is load up a bunch of assemblies that you didn't have access to automatically, like the Active Directory assemblies. And then there's the Windows PS module path module up in the gallery. That one adds the Windows PowerShell paths to PowerShell Core so that you can actually find modules that are installed into the Windows PowerShell directories. And then I came up with a module called PowerShim. What it does is it actually launches a Windows PowerShell exe behind the scenes, and then it does local remoting to that Windows exe, or Windows PowerShell exe from PowerShell Core, so that you can execute your Windows PowerShell commandlets that aren't supported in PowerShell Core inside PowerShell Core. So I'll show you guys a little demo of that. All right, cool. All right, is this big enough? Yep, all right. So the first thing you want to do is when you're set up in VS Code, at least on Windows, you can switch over to PowerShell Core by editing these settings inside your VS Code path here, or settings, user settings. So if I get rid of that, what it's going to do once I save it is it's going to say that my runtime configuration has changed, and would you like to start a new session? Click that, and it'll start up PowerShell Core instead of VS Code. So now if I do a PS version table, you'll see that I'm now running Core. Easy enough. So now let's kind of step through some of the things I just showed, some of those tools. If we look at the PS module path for PowerShell Core, you can see it's really short. There's just a couple places, you know, in your documents, but kind of in a different place. Program files where it's actually installed, and the VS Code directory, that kind of thing. So if I go and try to actually import one of the modules that's on this box, you're going to see something like this. The specified module is not found because it's not looking in the Windows PowerShell folder. So, like I said, you can import the Windows PS module path, call add Windows PS module path, and then when you look at your PS module path, you'll see a lot more stuff. Brought in all like the Azure stuff, Resource Manager, and then all the other directories that come along with Windows PowerShell. So now when I try to load import Active Directory module, it doesn't work because it requires a snap-in. It's actually a snap-in, which doesn't exist in PowerShell Core. So now it found the module, but it failed to import it. Well, we're kind of out of luck there. But what we can do is, OK, what if we want to just use the directory services .NET types directly? We could update our module to do that. So I try to execute that. What you'll find is this would have worked in Windows PowerShell, but you can see it doesn't find the directory services types because those aren't added by default in PowerShell Core. So if you import the PS Core Windows Compat module up on the gallery, it'll just import, and what it does is it actually adds these types. So now when I run this, you'll see it went out to Active Directory, and it brought back my username, or my display name. But that's all cool, but then we'd have to edit, change our entire module to use directory services rather than the Active Directory module, which currently isn't supported in PowerShell Core. So this is kind of along a similar vein to the import R module. It doesn't actually create the the shims or the proxy commands. All it does is expose this invoke shim kind of commandlet that takes a script block, and then that script block is actually executed inside a separate Windows PowerShell instance, and then over local remoting, it will actually execute that command for you. So you can see this time I imported my Active Directory module. I'm going to look at that user again, and it's asking me for credentials because it did this over remoting. So that should go out and return my Active Directory user. So like I said, this stuff is kind of not cross-platform, but this allows you to kind of see what some of the differences are between Windows PowerShell and PowerShell Core, and some of the things that you're going to have to do to just get your modules just to run on Windows. So let's jump back into the slides here. So some rules for our modules, kind of to live by, I guess. These kind of things probably were good best practice before we had Windows PowerShell and PowerShell Core, but now it's going to be even more important to do this kind of stuff. So you want to understand which commandlets exist on which platforms. Before it was like, okay, which modules are installed, but now it's kind of like, what does this commandlet even exist on Linux, or will it run on Linux? Like the Active Directory commands may never run on Linux, that kind of thing. Understand, which modules exist. Write cross-platform automated tests. So before, we were just writing Windows tests because that was the only place that you would run. But now we have to worry about, you saw all those different flavors of Linux and Mac OS X and all that kind of thing. So we need to be able to write automated tests to ensure that this stuff works. And then we need to kind of choose our top platforms to support. So Microsoft has chosen some flavors of Linux to run PowerShell on, that kind of thing, but there's a lot. So maybe your module doesn't need to run on all those platforms. Just think about your support matrix and think about what you're willing to say that your stuff works on, and then choose your top platforms. So it's cool to be cross-platform, but it might just be more work than is necessary if you don't actually need to support all those platforms. So there's a couple things in the module manifest you can do to kind of help. If you're running PS version 5.1 and up, you can actually set the PS additions or compatible PS additions flag inside new module manifest, and you can specify either desktop or core. The reason you can't do it in before 5.1 is that didn't exist, so you'll actually get an error when you try to upload it to the gallery. It won't complain locally, but when you go to upload it to the gallery, if you don't state that you support only 5.1 and up, it won't let you do it. The other thing you want to probably put in there is processor architecture. Maybe it didn't make a big difference before, and maybe it doesn't now, but there's the new ARM processor architecture you can put on there. The other thing is to tag your stuff appropriately on the gallery so people know that it's it can run either a particular operating system or maybe just on core versus Windows or Windows PowerShell. So now I'm going to talk a little bit about testing. So has anyone actually pulled down any of these Docker instances from the Microsoft Docker Hub place? So, which is pretty cool because they have all these different operating systems that come with the latest version of PowerShell core installed on them. So you don't have to try to set up a Ubuntu environment or CentOS environment, that kind of thing, to have PowerShell core running. You can just pull down these Docker images from Docker Hub and then write your tests inside, or execute your tests inside those particular Docker instances. All right, so I'll show you a little demo of that. All right. So I just have a script module. It's really boring. It just has one function that has get OS specific item, and then it just checks those variables that I was talking about before and returns a string based on what operating system it's running on or what edition of PowerShell it's running on. So if we're running on Linux, it just says running on Linux or running on Mac OS X or Windows. To validate that that's working, I've written a couple tests. So in a similar vein, I've used those variables again to only run particular tests on particular environments. So I can check to see if I'm running on Linux and then just run the Linux test like that. Pester, I think as of version 4.1, went cross-platform, so you can run your Pester tests now on Linux and Mac. But before that, you wouldn't be able to. So if you have just the pre-installed version of Pester, you're going to have to upgrade to be able to run Pester tests on PowerShell core. So I just have these two tests. One runs for Linux and one runs on Windows. So what you could do is spin up a Docker instance yourself and do all the stuff to copy the files in, execute the test, get the output, all that kind of thing. Or you can go on the internet and steal it from someone else. So this giant script here does all that. There's a guy named Dan Ward. He made a PowerShell beautifier. And this particular script he uses to test his scripts inside Docker containers. So what it'll actually do is all you have to do is specify the artifacts you want to copy in there, the script you want to run, the version of the operating system you want to run against, and it'll automatically spin up those containers, copy the files in, execute the test, and then turn off those containers. So it's actually pretty helpful. This should probably be in its own repository, honestly, but it's pretty cool. So I'll show you an example of doing that. So I just created this little invoke script thing. So I'm invoking that script, and then I'm passing in the source paths. So the source paths parameter just states what things I want to copy in there. So he actually uses a Docker copy and finds a temp directory inside the Docker container, and then just copies the files into that temp directory. You could do something with volumes if you wanted to, but that's just how he does it, and I didn't want to change it. And then test file and parameters is the actual thing that's going to be executed. So you could specify parameters here. I'm just running this particular script module test with the Pester test in it. And then you can list your test images. So I want to run it against Ubuntu 16.0.4 and Nano Server. And it's actually going to go out and make sure that you have those particular Docker instances downloaded and installed on your machine. It won't do it automatically, but it'll give you a really helpful message. I'll show you in a sec, because I don't actually have the nano server instance on this box.
Can you fully qualify those image names too if they're from different repositories?
You can. He just he's it's like a shorthand syntax for him. Because if you go look in there, he's just concatenating the Microsoft/PowerShell : just so you can just specify just the. So yeah, but you could change that stuff. So that's why I said this script should probably be somewhere else and shared a little more broadly. I think it's pretty cool. So we'll just run this guy and look at the output. So you can see it's starting up the Ubuntu container, copying those files in there. Now it's running that pester script inside there. And at the bottom there, you can see my pester output. It ran on Linux. It worked successfully, so that means that variable was evaluated correctly, and it returned the correct string, which is pretty cool. And then this is where it's stating that, OK, you don't have that nano server instance installed. So if you want to get that nano server instance, just do Docker pull and pull down that image. And then when you ran this test again, it would run on nano server as well. So that is testing. So this is like very applicable to both script modules and to binary modules, which I'm going to talk about in a second, especially binary modules. So let's talk a little bit about .NET Core. So how many of you are vaguely familiar with .NET Core? OK, cool. So the idea here is that we have a new .NET runtime. So for the longest, I think since early 2000s, we had the .NET Framework. .NET Framework is currently on version like 4.7, and it's been around for a long time, runs only on Windows. There was the Mono project. The Mono project was kind of a community-driven thing that went cross-platform, but it's not represented in this stack right now. .NET Core is the new thing. .NET Core, at least from our perspective, probably Microsoft's been working on it for a long time, is relatively new, and they're currently, I think, revving on version 2.1 of .NET Core. PowerShell Core is built on .NET Core, and Windows PowerShell is built on .NET Framework. So you're going to see this large block at the bottom, which is the .NET Standard Library. So for a while there, it really took me a while to wrap my head around this, but what the .NET Standard Library is just like a contract for what a .NET runtime looks like. So if you build your code to target the .NET Standard Library, that means you should be able to run on anything that implements that .NET Standard Library. So .NET Framework implements the .NET Standard Library, and .NET Core implements the .NET Standard Library. So that means if you target your binary modules to work with the .NET Standard Library, then they should be compatible in both runtimes. Should be. Building for .NET Standard, what you're going to do with your binary PowerShell modules is bring down the PowerShell Standard Library NuGet package. So that's up on NuGet.org, and there's two versions of it. There's PowerShell Standard Library version 3, and like it says, it's for anything version 3 and up. And then there's PowerShell Standard Library version 5, which works with 5.1 and up. All right, so some notes on deployment. Pretty much the same thing you would do with any other binary module. You want to include your PowerShell scripts, your PSM1s, your PSD1s, include your binaries. One difference is that if you want to work on machines that don't have the .NET Core runtime installed, or you don't want to ship the .NET Core runtime, what you're going to need to include is this .NET Standard DLL. So it's actually part of the .NET Core SDK, and that kind of puts the bits in place to work on .NET Framework things. And you just put that alongside your other binaries, and then it'll find that and load it up. And your stuff should work in .NET Framework Windows PowerShell. And then include any references. So I said .NET Standard DLLs, but pretty much anything you reference. And I'll talk a little bit more about references in a sec, because you can't reference things that aren't .NET Standard. So let's look at an example of this. We're good, we're good. All right, so I have this wonderful module here. And what they've done with the current or the newer versions of the .NET framework is made the CS projects much, much, much smaller, which is great. MS Build has become a little more intelligent. You don't need to specify all your files in there. There's just not a lot of cruft. So it's actually really, kind of nice to look at. And you can see on line 4 up there is the target framework. That's what you're going to want to target, .NET Standard. You can't target .NET 4.6. You can't target .NET Core. You have to target .NET Standard if you want one binary to work in both places. The other thing that you need to reference is this package reference. So that package reference is the PowerShell standard library. You can see I'm using the 5.1 version of it. If you wanted to do the 3.0 version, all you have to do is change this version number to 3.0, and then you would target the 3.0 version. So that's pretty straightforward. From there, everything should be relatively familiar if you've ever built a binary PowerShell module. So I have this commandlet, get beer. I like beer, and it's almost the end of this conference to go on that beer crawl, so I made this get beer commandlet. And it has the same, features that you'd see in any other binary PowerShell module. So it's got the commandlet attribute, you're extending from PS commandlet, it's got a process record, you have access to things like get variable value and session state, all that stuff's the same. So you should be able to just translate a lot of that code just straight over to .NET Standard. And you can see here, this commandlet is very similar to that script commandlet that I was showing earlier, where it's checking those variables. So I'm checking, if I'm running on Linux, I'm going to get a PBR. If I'm running on Windows, PowerShell Core. PowerShell Core is the hipster PowerShell since it runs on Linux too. So that's why it's an organic pineapple walnut West Coast IPA. And then Mac OS, they're just coconut water. So it's like all right, so to actually build these things, demo 3. .NET is pretty straightforward. You just say .NET build or publish. Publish will usually wrap everything up and put it in a nice little package for you to actually distribute. So that actually went out, built my commandlet, and now if we look in my bin directory, you can see I have a publish, and there's my DLL. And then if we go look at the run command, what we're going to do here is we're actually going to start PowerShell Core and then PowerShell.exe. We're going to import the same DLL. So this is coming from the exact same location in both places. And then we are going to invoke the getBeer command. So let's do that. Pop open those guys. And then I'll make that a little bigger so you guys can see. You can see that Windows PowerShell returned our hipster beer, and then we got the original West Coast IPA in Windows PowerShell. So same DLL loading in 2 different .NET runtimes. So yeah, woo! So because of this, it will also work cross-platform. So it'll work in Linux, it'll work in Mac, as long as we get into that next part I'm going to talk about a little bit here. So that's cool, pretty straightforward, right? So a couple things of note. Like I was saying before, anything that you reference, you need to include, and anything that you reference needs to be .NET Standard. So if you take a dependency on like some library that hasn't converted over to .NET Standard yet, you can't use it because you have to have .NET Standard all the way through for this to work correctly. And I'm going to show you a bunch of other caveats that I ran into with a little more of a complex module. So let's get into that. Has anyone played with Universal Dashboard? Cool. All right. So the idea here is it's a PowerShell module. It creates websites and dashboards and stuff like that. But it was my first PowerShell module, or cross-platform PowerShell module. So I thought I'd take the most complicated thing I possibly could and make it cross-platform. So some things that I ran into immediately that I want to talk about are first our native binaries. So it's all good and well if you have .NET Standard stuff all the way down. But I took a dependency on ASP.NET Core. So that's the actual web server that runs inside PowerShell that is serving up the page. And what it uses is it has a thing called Kestrel, which is the actual web server that serves the pages and stuff like that. So it has this low-level networking library called libuv.dll. Libuv.dll is like super optimized and very fast. They're actually looking to replace this in the next version, so we probably won't have to go through this headache anymore. But what happens when you compile against something like this, where it brings in a native dependency, your publish directory all of a sudden looks like this. So that's every single flavor of libuv for anything you could possibly run on. So if you look at like the PowerShell installer itself, there's all these different versions of the PowerShell installer. You bring down the one that was built for your stuff. So then they just ship a single native binary for that particular installer. Well, that doesn't really work the same for a PowerShell module because you want to put it up in the gallery and kind of have the same PowerShell module that everyone downloads. So you could have multiple PowerShell modules up in the gallery for each different version, but I don't know, that seems kind of like a pain in the butt, right? So instead, what I've done is I've just packaged all these in there. So when it loads up, it's got to figure out which one to load correctly. And usually with .NET like core apps, it will load the proper one from the proper place on the operating system you're running in. But with Windows with PowerShell, it doesn't do that because of the way that the assembly loader works and that kind of thing. Because we're loading all these things dynamically, it can't find that correct directory, so I've found. But if anyone else has a good solution to this, you should let me know, because this is what I had to do. I have to check which OS I'm running on. So similar to what I was doing in PowerShell, but now this is in C#. Check the processor architecture, and then determine which folder to go load that libuv from. So this won't be a problem anymore in the next version of ASP.NET, hopefully. But any other native assembly that you use, you're going to have to do something like this. So that was kind of a pain in the butt. And I have to do that before I spin up the web server so that that's properly loaded into my process, and then we can serve those HTTP requests. One thing of note is right on the documentation for what they call all those different folders are resource identifiers, or no, runtime identifiers. They say never construct a runtime identifier yourself. So that's like exactly what they tell you not to do. So then after I get that, that binary module or binary path, then I actually have to load it up. Which there's two different ways to do that. The top one is what you do in Windows. You pinvoke to kernel 32 and call load library, pass in the path. Or if you're running on Unix-based systems, you use libdl and do dl open. So same thing, loads up that binary module. And when I first started Universal Dashboard, they didn't actually have that PowerShell standard library, which meant that there was only this Microsoft PowerShell SDK library that targeted the PowerShell 6 stuff, and then there was the Microsoft PowerShell 5 reference assemblies. So then what happens there is you have to generate two binaries. So remember before I had my get beer command, and that worked well in both places, and I had one binary. Before the standard library, I had to do this, compile it twice. And that results in two folders. So you have two binaries, you have two sets of dependencies, all that kind of stuff. And then when you load up your module, what you need to do is you actually need to import the correct one based on which version of PowerShell you're in. So yeah, so if I was running Windows PowerShell, I'd load up net 6 or 4.6.2, otherwise the net standard one. And then it led to code like this. So not only am I producing two sets of binaries, my code's different depending on what I'm running in. So you can see I have an if-def that's only compiled in when I do .NET Standard, and then another if-def that's only compiled in when I do net 6.4.2. But then came the PowerShell Standard Library. Only one thing, right? I was pretty stoked. So I was like, hey, everybody, check this out. So it did. It reduced it by 26 meg. It sped up my build and eliminated all this if-def code. I was super stoked. But before I actually tested it. And I started running into this. So this is something that I still haven't overcome. So I'm glad you guys are in the room because you might be able to pass this on. I don't know if there's a good way to alleviate this. But I started running into assembly load problems. So who knows what an assembly resolve is? kind of a, maybe one person, two people. So the idea here is when .NET goes to like load an assembly and it can't find it, you can override this thing called app domain, current domain, assembly resolve, and then put an event handler there. And what the code looks like then is this. You're like, okay, well, hey man, here's where the path is, and you load it yourself. So it's kind of like working around a limitation of how .NET discovers assemblies, especially in PowerShell when we're dynamically loading things. We have to do something like this. Problem is, in .NET Standard, or .NET Core, they got rid of app domains. App domains don't exist anymore. So you can't use that assembly resolve thing in .NET Standard. You use the assembly load context. So it's like, okay, sweet, I'll use the assembly load context, which looks like this. It's the same thing. It's like, okay, I'm using the assembly load context, load my assembly. And it uses this thing called the system runtime loader. It's another NuGet package you pull down. Everything's a NuGet package now. You can see it supports .NET Framework 4.6.2, so it's like, oh, this is the holy grail. And then I actually tried it. So I actually have a demo of this.
Have you tried putting it in the manifest?
In the manifest? Oh, like loading it in the manifest?
I mean, the manifest has these assembly libraries where you put paths to the file.
Right. Yes. Because the problem is, here, I'll show you. This example kind of illustrates that. Because I guess I could, I don't know. I'll try. But I don't know. The main problem is that it seems like there are certain assemblies that are loaded into PowerShell, but when it starts, and then all of a sudden get conflicts between all these different dependent assemblies. I don't know. It was a pain in the butt, and I went down this like whole rabbit hole. So what happens is like if you here, let's do this. So the most recent version is the 4.3.0 version of the system runtime loader. Now if I pop open to my terminal, let's go over to demo 4. Oops. And then do a .NET publish, I guess. So that'll build it's the same module, same command. The only difference that I have here is I did one of those assembly resolve things. And you can see I'm using the assembly load context and everything like that. It built fine, built for .NET Standard and everything. So hooray, it should work cross-platform. So if you load that up, what you'll see is PowerShell Core works, but Windows PowerShell is giving me this loader error. Windows PowerShell wants, or some dependency wants, system runtime loader version 4. It's like, okay, I'll go to version 4. It's not the most recent, but it makes me feel dirty using an old one. So we'll downgrade, give it what it wants. Whoops. Do another, let's see, .NET publish. Compiles, everything's still happy, all the types are there, it's all good. So now it works in .NET Core still, but we're getting this problem where it could not load that type from that assembly. So the system, it's actually looking for a type that does not actually exist inside that assembly. So you can get past this. I've actually got past this system runtime loader exception thing, only to run into all kinds of other assembly load problems. So at the end of the day, I am PowerShell Universal Dashboard is now. Publish is not there. 1 second, I'll show you. It's now running in. I went full circle because now I have 2 different versions of the library again. And it's doing the thing where it's checking. So I deleted a whole bunch of code and sent out that tweet, and then I had to re-add all that code after I sent out that tweet. So it's close. I think it's close. I think maybe there is some way I can do this. I have struggled quite a bit, but I think fixing dependency errors like this are always a problem. So trying to get it to work on 2 different runtimes and multiple operating systems and stuff like that. I was trying to weigh my time over, is it really a benefit for me to actually make this .NET standard? So, all right. So that was a demo. So yeah, those are some of the caveats to the building cross-platform modules. Not all binaries are compatible, it seems like, with .NET Standard. It seems like they conflict with certain things in the .NET framework. System runtime loader is obviously one of them. Native binaries must be loaded or included and loaded by hand for each platform, which is kind of a pain in the butt. You can't reference anything but .NET Standard. So if you have your favorite .NET library that's still .NET Framework, you can't actually load or reference that. You could load it dynamically. And then my biggest problem is really just assembly resolution. Like, I don't really care if I can't load the system runtime loader. I just need to make sure that my assemblies are loaded properly in both places. So that's the biggest problem I ran into. So I guess calls to action. Use the PowerShell standard library when appropriate. Like you saw there, like it works really well when you're just kind of building a basic PowerShell module that uses C#. But maybe complex scenarios, not so much. Cross-platform testing is key, so check out that that particular script function. Maybe we can convince Dan to make it into a module they put up in the gallery for some Docker kind of testing. And then dictate what you support in your manifest to avoid problems. I think there's some other things. I don't know, there's not something in the manifest to dictate like the operating system version or operating system you're running on right now. I don't think so. So I think there could be some things that could be added to the manifest to make it like enforce some other things like that, especially since that's only going to be applicable to PowerShell core. So I want to thank you, and I want to open it up to any questions. Yeah. Is it both .NET Framework and .NET Core is what you're saying? Yeah, I don't think that I'm aware of that the required assembly is going to figure out which one it should load. So I think you're going to have to do that. Yep. Anybody else? Okay, cool. What? There, go ahead.
Have you played with anything? So one of the things I've been playing with is text UIs in PowerShell library. Have you? And some of them are supposedly cross-platform. At least one of those was using like Mono and was written before PowerShell core. Have you played with any of that stuff?
I have not played with any of that stuff. I know there's like GUI.cs or whatever that does that, and I really haven't played with it. But I'd be curious as like how the terminals are different in the different operating systems. So I mean, I think it should work, but who knows? I thought all that should work too. So. All right, cool. Well, I'll let you go to lunch a little early then. So thanks for coming.